And let me know when you're ready.
Yep, it's good.
Well, hello everyone, and welcome to the St. Louis Java Users Group. This is the June 2020 edition. We've been meeting online due to the pandemic, and so we'll try it this way until we know it's safe again for us to be meeting again in person. For people who've never been here before, welcome. Attendance is free. We don't maintain a formal membership list. Normally, we meet on the second Thursday of every month except December when there's no meeting because of the holidays. When we meet in person, we actually start eating and having a social period at 6 p.m. as people are gathering, and then the talk actually starts at 6:30. When we are meeting in person, our normal location is in the Object Computing Incorporated Training Room. They're at 12140 Woodcrest Executive Drive, Suite 310 in St. Louis. So we're glad to have you, and you can always watch the meetup group to find out what the latest presentations are. Let me introduce the other members of the steering committee. So from left to right, we have Ted Doyle, Todd Zimmerman, Bruce Alspaugh, that's me in the middle, Weiqi Gao, and Kathy Zwang. If you need to reach us on the steering committee, you can just email us at the address that you see at the bottom of the slide there. That's javasigsc@ociweb.com. And if you just send an email there, it will go to all of us. I'd like to thank our sponsors. Without the support of our sponsors, the St. Louis Jug would not be possible. I'd like to thank Object Computing Incorporated. They provide the room as well as the web hosting for us. They've been with us ever since the Jug started back in 1997. I'd like to thank Edward Jones for paying for our meetup fee subscription. That's what keeps the meetup free for you. It costs us money, of course, to be able to have a meetup group, and they cover that subscription cost. That's very nice of them. We also have two recruiters, Signature Consultants and Adaptive Solutions Group, and they sponsor food. They alternate when we are actually meeting in person. Sorry, we can't deliver food here over the internet. We haven't figured out a way to do that one yet. But they've been quite helpful. So if you're looking for a position, like a Java position or something like that, I would go ahead and contact the folks at Signature and Adaptive and let them know that that's how you heard about them, was through the Jug. We also are sponsored by JetBrains, and when we meet in person, we've been raffling JetBrains licenses. Problem is, when we've been online like this, we haven't figured out a really good solution to be able to raffle off the JetBrains licenses to people who attend. But this month here, we're going to try something new. I don't know how well it's going to work. We've never done this before, but we'll take a stab at it. I'll get back to that in a moment. I'd also like to thank Elastic. They're the people behind Elasticsearch, and they've sponsored some gift cards for the raffle as well. I'd also like to thank Intertech. They sponsor the famous screaming flying monkeys that we raffle at the end. If you throw them up against the wall, they scream, and they're just a lot of fun. We also have Manning, who sponsors ebooks, and Pearson, which also sponsors ebooks. So as far as upcoming presentations go, we do have it set up so that on July 9th, the next meeting will in fact be online. So you can go ahead and RSVP for that now if you're interested. It will be on migrating beyond Java 8. And Dahlia will be introducing some tools that you can use to check your code base to find out if there's any issues that you might run into if you try to upgrade to a newer Java version beyond Java 8. And these are free tools that you can use and it looks to me like it would be a pretty good presentation. On August 13, we have scheduled Architecture Foundations, Styles, Patterns, and Trade-offs by Neil Ford. He gave a presentation at DevNexus in Atlanta that was of this, and it was just absolutely packed. And then on October 8th, we have This Ain't Your Parents' Java by Venkat. He'll be coming back, and he's always a good presenter on new features coming up in Java. So I would encourage people to go ahead and watch the meetup group. That's meetup.com/gatewaychug in case we need to update the presentation schedule and the location. If you go ahead and RSVP, you'll get the update if we need to make any changes. We're always looking for people who are willing to give presentations at the Java Users Group. So if you're interested in giving a presentation, or if you would like to sponsor the JUG, just send us an email to that same email address that I gave earlier. That's javasigSC@ociweb.com. So to back up just a little bit before I turn things over, when I was getting to those sponsors, we do have some JetBrains licenses, and we were just talking a minute ago, is there any way we can raffle those online? So Ted, who is also on the steering committee, is here right now with us. And so if you would like to be, hi Ted, you can go ahead and wave. I don't know if people can see you, but he's there. So if people would like to participate in the raffle for a JetBrains license, we're going to try something new. In your chat window, if you were to type in your name and your email address to indicate that you're interested in participating in that raffle, Ted will copy and paste all of that into a little website that will scramble those names and email addresses randomly. And then we'll just pick however many licenses we have. I think, I'd have to check again, but I think there's 6. Don't quote me on that. And we'll just raffle and until they're gone. So if you're interested, down in the chat window, you just put in your name and your email address. Ted will copy and paste it, and we'll do that raffle at the end of the presentation once it's over. So you got to stay to the end.
And people are chatting to me privately, which means that if they keep on doing that, that means it won't interfere with questions going to the speaker. So.
Okay, yeah, that's a good idea. So if you could just send that to Ted privately, that won't interfere with any questions that you might have to ask the speaker. Then we can just collect things up that way. I should point out, a lot of people may already have a JetBrains license right now. From what I understand, if you win one of these, you can use it to extend a license that you already have by an additional year. Also, you're free to give that license number to somebody else. The important thing is they do need to be redeemed, or JetBrains will stop sending them. Because they always want to account for them. We send out these license coupon codes basically, and if they're not being redeemed, they're like, hey, are you still active? So that's what's going on with those. So if you want to participate in that raffle, just tell Ted. All right, so at this point, I think we're ready for tonight's presentation, developing low latency applications with Hazelcast. Sharath, would you like to take things over from here? I'm going to stop sharing my screen and mute my microphone so you can give tonight's presentation.
Sure. My name is Sharath Sahadevan. I'll turn on my video for a few minutes here, just for the purposes of bandwidth and stuff. I'll turn it off in a few minutes as I launch into my presentation. But first off, thanks for giving me the opportunity to present to the St. Louis Java SIG. I appreciate the opportunity, and I appreciate all of you taking the time on a beautiful evening to attend. So what I'm going to talk about, I have a deck that I'm going to share, and then we'll launch into it. Are you able to see my screen?
Yes, I can see everything and I can hear you okay. Looks good to me.
Awesome. All right. First off, Hazelcast has two products. One is the in-memory data grid, and the other is Jet. Now, anybody in this group familiar with Hazelcast or using Hazelcast products? If so, just pipe up and say yes or type something in the chat. I know we have some clients in the St. Louis area that are actively using it. So, but these are the two products we have: in-memory data grid and Jet. Basically, the use cases for us are anywhere that you see latency in your applications, and we'll go into that further. So basically, this one is an distributed in-memory data grid. So basically, you use it to cache data that you want to use often. You don't want to go back to the database often. All the data is kept in RAM, and the clustering is very easy. You can have a number of members, and you add members, and they will automatically find each other based on the configurations, and they will back up data. Or the partition data is backed up in the nodes. The language Hazelcast itself is written in Java, but your client languages can be any of these specified here. And what I've seen is it's very easy to start. Especially if you're a Java developer, there are two modes, and we'll touch on that. One is the embedded and the client server mode, but it's as easy as include the items in the jar, and run your instance, and you got one Hazelcast member, and then you bring up additional instance, and they'll find each other and talk to each other and form a cluster. Some of the advantages, easy to scale out, resilience in your applications, simple programming model for developers, and then fast application performance. That's where we shine. I mean, as you scale up and have significant amounts of data held in your cache, that's where we shine. We are partnering with Intel on their Intel Optane DC persistent memory. And that's, the Hazelcast engineers are working with Intel's engineers on that. So the key differentiators that we have, I'm not going to read through each of these, but rich API set, easy to get started, high performance, and I'll show you another chart where it's a pretty busy chart where you can run it in all the different environments, either on-prem or in any of the public clouds. So this is it basically shows you all the IMDG capabilities. So if I start at the top, you're basically looking at all the different languages, client languages that you can use. And then near cache capability is, if you have a client server model you're using and you want to bring the data closer to the clients, and you can have a near cache sitting closer to the client, and then when it's invalidated on the cluster, you can get a message. You can listen for events saying, hey, that data is invalidated. Then you have to go back to the cache or eventually to the database to get your data. Serialization is very important. What kind of serialization people use? It can, because as these are high performance applications, and if you have to serialize and send it over the grid, that's where some of the latency will come. So trying to keep that to a minimum is a science. And then these are the various objects that are supported within Hazelcast. Map, this is similar to, if you're a Java developer, you probably recognize a number of these number of these data structures. The thing with Hazelcast is that it is distributed across the nodes. So a map that you put on one node will be available on the other also, in the sense that they'll be able to find that data. It's not restricted to a single JVM. And then, you can search the data that you have saved using either SQL or what we call predicates. And for people who are familiar with messaging, we have queues and topics, similar to the JMS queues and topics that are available for members to talk to each other or for the clients to talk to the member nodes. And then, if you want to do some bulk processing on all the data that is there, we have ability to load what we call entry processors. These are classes that you can write and run on the cluster itself so that it's closer to the data. And then you run the bulk processing and then just send the results back to the clients. We have switches, for AP and CP subsystem, basically coming from the CAP theorem. And, so if you want some of these data structures that you want to use in your application, then you use the CP subsystem switch. So basically it's a configuration. Some of the member nodes can run in this mode, while the others run in the AP mode. And one thing I want to point out is partition management comes out of the box. Typically, if you start up one node, you will see that there is 273 nodes. If you bring up the second node, the sharding automatically happens, and 135 will be on one node and the 136 on the other. And basically, Hazelcast automatically handles all that, and I'll try to show you some of that later in the demo. And then you have on-heap and off-heap storage. So as you scale, a GC process can become long as the amount of data in the distributed cache increases. So I think Hazelcast has an innovation called high-density memory store, which basically is off-heap memory that the distributed cache can access faster. And everything in blue is an enterprise feature. Everything in orange is, we have an open source version. We call it our professional, along with support that comes from Hazelcast. And so you can get started with that. And as you scale up, you move to enterprise features if you need any of these highlighted in blue. And feel free to stop me and unmute yourself and ask questions as you see fit. And I can pause and take your questions. Or you can throw them in the chat too. Hot restart store is a capability where if one of the members, one member nodes dies, on restart, the restart time can be long if you have to go back to the database and warm your cache again. So there is a capability where some of the data can be, the data and the live data in the cache can be written to a disk, and then on restart, on an unplanned failure of a node, even it comes back up, it can just read off of its disk so that it'll quickly load the data. And then here are the different environments we run in: on-prem, GCP, AWS, Azure, Kubernetes, pretty much all the popular, commonly in use environments. Management Center is the way you get visibility into what is happening with your Hazelcast nodes. And then we can run on PCF, OpenShift, IBM Private Cloud. We have a security suite that, if you want encryption, you want TLS, JAS authentication, authorization, all that capability comes with our security suite. WAN replication is basically you have a primary center and a data and a secondary center, and you want the data from one site to another from the Hazelcast caches. So that's WAN replication. Rolling upgrades is when you're doing an upgrade, you want to upgrade one member node, And then if that's successful, then you migrate to the other nodes. So basically a node downtime upgrades for your entire cluster. Blue-green deployments and automatic disaster recovery. I have a couple of slides where we can go deeper into it. But it's the common blue-green deployment phrasing where you're probably familiar with it, where you set up, you have a production cluster that's running, then you bring up a secondary cluster, you do the upgrade there, and then switch all your traffic over to the newer cluster when you're ready for it. Similar capability with the automatic disaster recovery to the backup site. And then we also have ability for you to monitor Hazelcast through JMX or REST APIs. So I said a lot here, so I'm going to pause and see if anybody has questions. Feel free to unmute yourself. I'm going to check the chat here to see if there is anything. Nothing. Any questions at this point before I move to the next slide? Awesome. And then this is the, from a support perspective, what is the difference between the, pretty much, what we saw in the previous slides, except with the additional of support SLAs. And then technical use cases, primarily caching for the in-memory data grid. Web session clustering, microservices infrastructures wanting to share data across their microservices. And this is again, talking about how much we can scale. We're seeing massive scalability at this time, and this is getting pushed every day. That I look at. So this is a common use case. Basically, you have some systems of record. You want to load that data into a distributed cache, and you want your business systems accessing that. And I see that a lot out in the field. And basically, this is a client-server model for this, where the application A is accessing the grid here and getting data from here. Similar picture showing a client talking to the Hazelcast cluster, and where you want the business logic. We talked about the entry processor. You can sometimes put the data logic on the Hazelcast servers itself, so that it's processing the data on the cluster itself in a client-server mode. We also touched on the availability of messaging. So, that is the publish, subscribe mode that's available. These are the various member nodes in here. There is a topic bus, and the clients are all able to publish and subscribe. Pretty similar to what you see like in a JMS or anything that you're familiar with. And for a microservices infrastructure, you say you're running on PCF, Kubernetes, you can have Hazelcast installed and have your data cached there. Nothing additional to add on this one. This is the two different modes I talked about. One is the embedded mode. The other is the client and the Hazelcast cluster are separated. So in the embedded mode, basically, in your Java application, you package the Hazelcast jar and just start up your application. That's one instance of Hazelcast. That's one node of Hazelcast, along with your application. And then if you start multiple instances, they will find each other, and the Hazelcast instances will find each other, and they will talk to each other and will distribute the data between themselves. Here, there is a separation of concerns where the application is completely separate. You can written in different languages, and then it's talking to the Hazelcast cluster. The advantage here is separation of concerns. You can tune the application and the Hazelcast cluster separately. You can use different languages to work with the cluster. So I see both these in the field, easier to get started in this mode. And then, if you have multiple use cases, sometimes and you want to optimize the cluster and get reuse out of an existing cluster, it might be better for you to be in a client server mode. Web session clustering is pretty common use case I see. So if you lose one of these servers, the session data is stored in the cluster and is available to the applications. Blue-green deployment. This is, we have two clusters. All the clients are initially talking to one of the clusters, which is your production cluster. And then you have this is our Hazelcast Management Center. These are the different clients. These are the two different clusters we are talking about. And you can flip the client by using allow denied lists from one cluster to another. And you might want to do that. You flip, say, client one from enterprise cluster A to B, make sure it works, and then you repeat that with the other clusters. Commonly used if there is a upgrade process and you do not want to do not want to have any downtime for the entire cluster or the clients. All right. And then similarly, for DR, the Hazelcast client can be configured so that it senses that the entire cluster is gone. The primary cluster production cluster is gone, and it can automatically switch to the disaster recovery cluster if needed. All right. This is WAN replication, which is, I touched on it before. I have one cluster running in one data center, secondary cluster running in another data center. So, think of it as maybe a active passive scenario, and all the data in the cache from in one DR, one production site is being replicated over to the other cache and immediately available, so that you don't lose any downtime. Now it can be one way or two way, whichever way, depending on how you have it configured. All right, the second product that I mentioned was Hazelcast Jet, and think of it as data in motion. So IMDG is in-memory data grid, basically for data at rest. This is what, we loaded data from the systems of record, kept it in memory for fast processing. Now, what we see also in the field is that there is a lot of data that you are taking in from different sources, and maybe you have to do some kind of processing on that data. You ingest it, you have to combine it with other data, some kind of enrichment needed, and then you might have to do some additional processing on the data, transform it, and then push it out to another sink. And here are all the sources that we work with. It could be Kafka, it could be IoT edge devices, could be any enterprise applications. You can have custom connectors, our in-memory data grid, commonly, file watchers, whether it's ETL processes that you see, it can be sockets, database events, any of these. You get the data from any of these things, ingest it, and then maybe you want to just pump it into the in-memory data grid for later use, or send it to any of these sinks. So this is something I see in the field also. All right. And then, we also have a managed service, which is our Hazelcast Cloud. And I'll show you a quick demo of that also. You can sign up for that at this site right now if you want. Just go up there and, there is a starter version that you can sign up for, and, you can set up your cluster, have a client downloaded, You should be able to connect to it in no time. So that's our managed cloud, and I can show you a quick demo of that too. All right. Let's see. I think we are an open source company. So if I know there are a lot of good Java developers here. So if you're interested in contributing to open source, check out these two sites, and you can look at the issues there. And we welcome your contributions. If you need to get connected with any of the engineers, happy to reach out to me, and I'll also show you where you can reach out to the team in how we communicate with the community. So here are some useful resources for you. If you go to Hazel, and I'll take you to some of these, hazelcast.org. You can download the software there. All the demos that I'm going to show this cloud demo. Any training that you want is available at training.hazelcast.com. And then, if you sign up for these Google Groups, if you have questions on Hazelcast, you can ask either on Google Groups, Stack Overflow, or Gitter. There is one, this is for Hazelcast, the IMDG, and then there is one for Jet also. You can find those two there and post your questions there, and somebody will get back to you as soon as they can. So with that, I'll pause and see if there are any more questions. That's much for the presentation, and then I'll launch into a couple of demos that we can look at. Any questions at this time? All right. If not, I am going to stop my share, and then I'll share my screen here with for the demos. So give me a minute while I set that up, and then we'll launch into it. So I'm going to share my screen. So first thing I want to show you is, where you can download all the software. I will bring that up. So if you go to hazelcast.org, there are two good links here, IMDG and Jet for the two products. So if you want to download the in-memory data grid, you can just go in here, go to downloads, you'll see the latest version. And what you see here is code samples, the zip file that you will need, and then you can get started with it. So that's for the in-memory data grid. Similarly for Jet, and again, all the documents, you'll see the reference manual, release notes, all this information you can find. 4.01 is the latest stable. And I think the any previous version also you will be able to find here, and you just say see all archives. And then similarly, Management Center, you can download the Management Center and look at it here also. And if you click on the see all archives, you will be able to find all the older versions also. So that's where you find the code itself. And then, so for me, I have deployed, I have Hazelcast 4.01 downloaded. And I'm going to launch into a couple of demos here. So if you see, I'm going to start up my Management Center here. Basically, that's so there is, if you go into that folder after you download in 401 Management Center, you'll see a start.sh. You just have to run that. It's going to launch my Management Center here. And then if you notice, it brings it up at localhost 8080. So I'll leave that running there. And then, in the download that you have, you'll have a start.sh at the demo folder. If you go in there and say start.sh, now I'm bringing up the first cluster. So you see that it says member, this is the member, I'm running at port 5701. Now I launch into my Management Center view. Let's see if I have that already. So that is my view of the management center. It shows one client. The Hazelcast management center is reporting itself as a client. And there is one member, which is that 5701 that we just launched. You can come in here and look at all its configurations. You can shut down members here if needed. How many partitions are owned? What is the member version? Now, if you notice, the maps here are 0. So now what I'm going to do is I'm going to bring up the second node. And for that, I'm going to use one of the samples. So the code is here. If you download the samples from the site I showed you, you will see a number of examples. So if you just take this simple map test, this is the code for it. And you should be able to download it at hazelcast.org as I showed you. And basically all this does is it's going to launch this example, and then it will pump data into the cluster. So I will run it at this time. Let's see. So it is bringing up the second node at this time. So it's telling me that, hey, I discovered 5701 and it's trying to join. So now you see, I joined the two nodes joined, and it is pumping data. So now if I go back into my management center, I should be able to, in a few minutes, if everything works right, see, you should see the second member, and you see the number of partitions. So you see Hazelcast has split the partitions. There is data here in the map. You can get the map data here, and automatically, you know, the data is backed up. If you have two nodes, the data is partitioned and it is backed up in the different nodes. So each of the nodes will have a backup. And if I shut down one of these nodes, you will see that, or if I bring up another node, you'll see the number of partitions will change. So we can do that. If I say I'm going to bring up another application, say like the chat application. So that is also packaged there. And if I try to run it, so now I'm running 1, 2, I should see 3 nodes of Hazelcast running in a few minutes. So it discovered the 3 nodes, 5701, 02, and 03. And let's see. And let's see the data here. So we should see. So I see the three nodes. You see the own partitions have changed. It's 90 on each. So basically Hazelcast by default, so it's having a chat application. It's a different map. You see all the statistics on that. So basically now if I go in and kill one of the members, let me go in and stop one of these members. I can just say stop the chat application. So now I should only have 2 nodes once this terminates. So this is terminated. And you see there is 2 nodes, 135 own partitions. There should be no data loss between the two nodes. So behind the scenes, Hazelcast in a distributed manner finds all the nodes and then processes and keeps the data without the user knowing anything about it. So that's the beauty of, I think, how easy it is for you to get started with the caching solution. Now there is a lot behind this, but just from a simplicity to start with, you can just take some of our examples and get started with pretty easily. So with that, I'm going to stop this one also, and I can shut down. Let's say I shut down this node also. So now I've stopped simple test, and I should only have 1 node running at this time. And we should still not see any data loss. both the maps are there, the default is there. Now all the partitions will be owned by just one. All the 271 partitions are just owned by this node. Now if you shut down this node, since everything is in memory, I will lose everything. So that's a quick demo of how easy it is to get started with Hazelcast, to get some visibility into what is going on with the management center. Any questions on this? All right. And it's great. This is great information to have for debugging and things like that once you're running in production. So with that, I will pause that. So that is basically what I've showed you so far is Hazelcast running on my local, and getting visibility, how easy it is for it to discover the different nodes, and as the nodes drop out, how it rebalances and partitions the data. And that's all happening behind the scenes for you. The next thing I want to show you is, with that, I can stop, get out of the management center. We will stop these. Stop. So that was the demo one that I stopped. Now this is the management center I'm going to stop. So management center is also shut down. The next thing I want to show you is, let's see. I want to show you about our cloud itself, our managed cloud instance. So, any questions on this so far? Let me check. How is this different from other caching solutions in terms of memory usage and where it stores its data? Hi, Rohit, I see your question. I think, the key is, I think there are lots of caching solutions available. I think for us, we shine at scale and simplicity to start with. So those are some of the key things. I think we've published benchmarks. If you go to hazelcast.com and look at some of the benchmarks, I think we shine in terms of, if you have use cases where you stress the system, and then with some of our innovations like hot restart, and you can minimize the number of nodes you need and get maximum performance. I think the key with Hazelcast is there are lots of knobs and switches you can turn to get optimal performance from the system. Does that address your question? Awesome, thank you. All right, let me see. All right, I wanted to get to the, I want to show you the Hazelcast Cloud. See if I already have a window. If not, I will launch a new one. So this is an existing cluster that I have. And that's a cluster. So right now it's stopped. So you can go to hazelcast.com and sign up for it. I'll show you where. Go to this page, you see products and services. There are 3 of them. You just go to Hazelcast Cloud and you can click on the start for free here. It'll give you a starter version that you can get started with, and you'll get access to something like this. Basically, I can manage my own cluster. If I say resume the cluster, it'll start the cluster in a few minutes. And then you have the ability to download a client in the configuration. Once this comes back up, I will show you where I can, I have a client already downloaded. So in my window, if I go to Hazelcast, so you will be able to download a client like this. And basically it will have everything you need and instructions to run it. So let me refresh this. So my cluster is resuming at this time. And once it resumes, I should be able to, so here is my code for the client itself. And the client can be in any language. This is mine. This is mine in Java. And you just say run.sh and it will try to execute against the cloud. So basically, once you get, it's taken a few minutes to resume. There it is. Now it is a cluster, and I should just be able to run this guy. So once you do that, you see that everything is connected. It's trying to put data in the maps, and then you have visibility into what you're putting in here. It'll as it refreshes, it'll show you the metrics and the data here. And the beauty of this is here you can go in and download any client you want, and you start them up, and it gives you instructions. You download it, it gives you instructions on how to start it. So that also you should be able to do today. And this is the starter cloud. It's free. And then if enterprises, so here you see that it's one client. If I start multiple instances, you will see all this data increasing. And so I'm going to stop this at this point. But you can play with this if you're trying to learn Hazelcast, get feel for it, and don't want to download things, but just want to experiment on the cloud. Right now it's running on AWS, but it's coming on any of the other clouds, the managed service. If you want to set up Hazelcast by yourself, you can do that today on any of the public clouds. Awesome. With that, and then you'll find the documentation and things like that here. So that's all I had to say about the cloud. There is one more place from a demos perspective. There is a real-time flight telemetry demo that I will run on but if you want to watch later, go and see, you can go to jet.start.sh. You'll see there's wonderful tutorials here, and then all the demos are here. So if you go to here, you want to play with some of the, writing your first jet program, just walk through this, and it'll show you how to set up your jet program and process things. And then there are additional tutorials on how to run things from Kafka, MySQL, whatever you want to do, and number of programming instructions in how to build pipelines. The pipelines that we saw in Jet, you build through code like this. So that is that, and then I'll quickly run through the flight demo. You see all the code for the demo is available on GitHub, so you should be able to download it, and you can so you can go here, try to download and run these demos by yourself if you want to. So basically, I will just follow the instructions here, and so in my demo here. So first thing is I want to do that brings up the Grafana pieces. And then here are all the instructions that you saw on the GitHub site. And then I will do a Maven clean package. So this is the flight telemetry demo using Jet. Then now the Jet node has started. It's going to be getting data from different airports about file landings and things like that, real time. And I'm pulling in that data here. So you'll see as we refresh. So it monitors a few airports and shows you the how much are taking off, landing at these different airports, and that's the so that is basically real-time streaming of data and with Jet, and all the code for that is available here. If you want to look at it, you should be able to download. I think it pulls the data from ADSB, and you'll need a key for that, and the instructions are all right here. So that is the extent of my demo. I'm going to stop share, and I will pause and take any questions you have. Are you running the demo in embedded mode? Yes, all the ones I ran were in embedded mode because when I showed you the demo client, basically if you look my pom.xml, yeah, this one is a client, right? When I'm on the cloud, when I was connecting to, the cloud is where the Hazelcast cluster is for the managed service. So that was a client server. So you can tell by, I think in the code, you tell whether it's a client or a member node. The APIs are different in how you call it. So the downloaded code for the sample client for the cloud was a client server mode. Everything else was embedded mode. Awesome. With any distributor, there is the cap consistency. Yeah. Yeah. I think, if you go back, Bruce, to your question, which one does Hazelcast selected? That's why we have the CP and the AP switch. If I go back to my presentation, so Hazelcast has the ability for you to configure which way you want to do it. So if I go back to my deck, let me see if I can get back to that page. There is a CP and an AP switch, yeah, right here. So I can say this is the AP mode. Most of my members are running that. And then some members I can enable for CP subsystem, or the entire cluster you can run in CP subsystem. So basically there are switches. Awesome. Any other questions? I'll unmute everybody. So I'm going to, in case you are muted. Let's see. Yeah, feel free to unmute yourself and let me know if you have any questions. I'll unmute all of you. That's all I had. Any other questions I can address? Very good. Let me see if there's any more that I did not address. Awesome. With that, I'll stop my recording.